Hi everyone, in this video we will study how to insert a node in a red-black tree. As you can see, I have split the screen into two halves, and on the left I have the pseudocode and on the right I'm going to walk you through the different cases. Now the way an iPad works, I'll not be able to annotate the stuff on your left, that is the pseudocode, but I'll be annotating the stuff on your right, that is as we go through the different cases. Now, if you look at the pseudocode, what we have is we have an insertion in a red-black tree. The first thing is you just insert the node in the tree like a simple tree insertion, like a binary tree insertion. Okay. Now, when we insert a node in a red-black tree, we will color this node red. Now, if you don't know the reason why we want to color the node red, I'll ask you to watch the previous video in this playlist. The main reason is that it will only violate the third property of a red-black tree, which is the parent of a red node has to be black. Now we'll go into the pseudocode in depth, but what I want you to understand is there are in all 6 cases. On your screen, you will only be able to see 3 cases. This is because we are only going to consider one part. The other part will just be the same, just that you'll have to substitute the left with the clause left with the right. Okay, you just have to swap them. Now, let X be this node that you're going to insert. What you are going to first look at is the parent of X. Now, the parent of X is denoted by P of X. That's the parent of X. Now, let's look at the while loop. So it says that while X is not the root of this tree and the color of its parent is red. Okay, so that is the condition in the while loop. So what you're going to do is, if that condition is satisfied, then you have this do if. Okay. Now, if your parent is the left child of your grandparent, okay, that's what this sentence means, or the statement means. Do if px equal to left of p of x, which is your parent is the left child of your grandparent. Okay, if that is the case, that your parent is the left child of your grandparent, then you're going to look at your uncle or your aunt, which is the right child of your grandparent. Okay, so this is where you're going to get 3 cases, and if your parent is actually the right child of your grandparent, you'll get 3 other cases. So we're just going to study the 3 cases here, and then if you substitute left with right and right with left, you'll get the other 3 cases. Okay, so we're now looking at your parent first, where the parent is the left child of the grandparent. If that is the case, you're going to look at the aunt or the uncle, and that is what we are going to denote by Y here, which is the right child of your grandparent. That is, Y is right of P of X, which is the right child of your grandparent. Now, Y, your uncle or aunt, can have 2 colors. It can either be red or it could be black. Now, if your uncle or aunt, that is the color of Y is red, you're going to encounter case 1. Otherwise, if the color of your uncle or aunt is actually black, then you're going to consider 2 cases. That you're going to look at whether X, you yourself, are the right child of your parent, in which case you will encounter case 2. Otherwise, if you are the left child of your grandparent, then it will go to case 3. So basically, the important thing, the way this code is written, if X is the right child of the parent, then you will do case 2 and then do case 3 as well. But if X is the left child of your parent, then you will just do case 3. That's what the else if X equal to right P of X, then case 2 falls into case 3 means. Okay, so let's understand all this with a few examples here. So note that we're going to insert the node. When we're going to insert it, it's going to be red. And then you're going to consider the case that your parent is the left child of your grandparent. And then you're going to look at the uncle or aunt, which is the right child of your grandparent, which is Y. Okay, so let's first look at case 1. Now here, in this case, what we have is, this is your X right here. Okay, that's your X. Now, X is B. And as you can see, X is basically your parent, that is A in this case, that's the parent. It is a left child of your grandparent, and your grandparent is C. This is your grandparent here. So X is B in this case 1, and its parent, which is A, is the left child of the grandparent, which is C. Okay, so this is where X is. Now, what would you do in this case? Now you'll first look at the uncle or the aunt, which is, in this case, is the right child of the grandparent, which is D. So this is your uncle or the aunt. That is Y. Now you're going to look at the color of Y, which is red in this case. Now, if it is red, this is case 1. And what is case 1? We will just apply recoloring here. So we will color D to black here. And then what we are going to do is, you're going to color C to red. And now C will become the new X. Now you might be a little confused as to what do you mean by new X? This isn't a loop, the while loop. So the way violations are going to be addressed is, you're going to start from the leaf and you're going to push the violations up the tree till you reach the root. So that is why the while loop is X not equal to root of the tree. So you're going to keep pushing violations from the bottom, that is from the leaf, all the way to the root. So when you first insert an element, it is going to be as a leaf node, and it's going to violate some properties. And then you're going to fix those properties and push them up. For example, here, you see this was, say, some iteration of the while loop, where B was where the violation was occurring. And what we did after this recoloring is, we pushed it one step above to C. So we are pushing the violation up the tree. That is what we are doing. Okay, so just to iterate what we did here, so that we can recollect everything very clearly, we were looking at X, and we looked at its parent here. And the parent of X is the left child of X's grandparent. Okay, so A here, which is the parent of X, is the left child of C. Therefore, what we do is, we look at the right child of C, which happens to be the aunt or uncle of X. Now, first we look at the color of this aunt or uncle, which is Y and which happens to be red. If it's red, it is very simple. We fall into case 1, and in case 1, we just recolor D, that is your aunt or uncle, to black, and your grandparent to red. And what do we do is, we now assign X to essentially C. And then we apply the algorithm again. Okay, so this is what is going to happen. Now, but suppose it can happen that your uncle or aunt, which is Y, is not red, it is actually black. Therefore, we'll fall into case 2. Now, in case 2, Y is denoted here. Now, let me just choose the correct color here. So this is your Y, and it's black. Now, if you look on your left, the graphical notation, it says that a tree denoted in that manner, it's a subtree with a black root. So Y is black. So if Y is black, what we are going to first look at is, where is X located with respect to its parent? if y is black. That's where that's what we're going to do. So if x happens to be the right child of its parent, so this is x and it is the right child of its parent. Okay, so x is b and b is the right child of a. Now if this happens, what we are going to do is we are going to encounter case 2. Now when we encounter case 2, the case is pretty simple. We are going to left rotate A. Now what does left rotate A entail? When you left rotate A will move this side. Okay? And B is essentially going to move up. That's what you are. That's what is going to happen. You're left rotating A, so A is kind of falling down. B is going to go and take its place, and you will have this particular tree. Note that this is not complete. If x is the right child of its parent, as is the case here, then what we've done is we're going to first left rotate A. And once we first left rotate A, you will see that that will be transformed to this tree that you can see here, and you will reassign your x. So whatever was A here is what is going to become your x. And this is not the end of this case. Now after doing case 2, you'll also do case 3. So case 3 happens if x is the right child of its parent, you'll have to first do case 2 and then you'll have to do case 3 as well. But if x is the left child of its parent, you'll only do case 3. That's how this code, the pseudocode here is written. Okay, so if x is the right child of its parent, do case 2, it will transform to case 3 and you do case 3 as well. If x is the left child of its parent, you'll only do case 3. Okay, after this transformation to case 3, you will see that x is the left child of its parent. Okay, so it's a left child now, so we'll now go and solve case 3. Okay, so in case 3, what we are going to do is you are going to right rotate C. Okay, so you're going to come here and C is going to be pushed down like this. Okay, that's what right rotate C means. If you push C down and then B is going to move up like this, and then what you're going to do is you're going to color B to black and C to red. That's what you are going to do. So you, in this rotation, when you right rotate C, C will come down, B will move up, this will now get attached to C. The subtree, the right subtree of B will become the left subtree of C. And once you do this, there will be no more violations of property 3 in the red-black tree. Not at all. Okay, so this is how we will solve the problem when we insert a node in the red-black tree. So before we finish this, I just want to go over this whole thing real quick one more time so that we can understand this. This is pretty complex and it's pretty difficult to understand. So really, it's good to just go over it again. So whenever you insert a node in a red-black tree, the first step that you're going to do is you're going to insert it like a normal binary tree insertion. And whenever you insert it, you're going to make sure that the node that you insert is red in color. This is because if you insert a node that is red in color, only the third property is violated, which is a red node has to have a black parent. Okay. After that, what you're going to do is you're going to go through this tree, starting from this leaf, and you're going to push the violations up the tree. And to ensure this, there are two conditions, which is basically a while condition, that is x not equal to root and color of parent of x equal to red. Okay, when this and condition in this while loop holds true, you will go inside the loop, otherwise you'll just exit this loop. Now, what you're going to first do is you're going to look at parent of x, which is denoted by p of x, and then you're going to see if the parent of x is the left child of its grandparent, that is left of p of x. Now, if this is the case, what you will have is three different cases: case 1, case 2, and case 3. If your parent is the right child of your grandparent, you'll have three different cases. And whatever code is written here, you just have to substitute left with right and right with left. That is, just left and right have to be swapped. Now, next what you're going to do is you're going to look at the color of your aunt or uncle, which is, in this case, happens to be the right child of your grandparent, because your parent is the left child of your grandparent. We'll call that Y. And first we'll look at the color of Y. If the color of Y is red, what we encounter is case 1. Case 1 is pretty simple, and all that you need to do, as is shown in this slide here, you just have to recolor D and C. Okay, that's all that you have to do. Recolor, and C becomes the new X. That is, you push the violation up the tree, and then you try to resolve that violation. If Y happens to be black, then you have two cases that occur. The first case occurs when X is the right child of the parent. In that case, what you're going to do is you're going to first left rotate A, as is shown here. You're going to left rotate A, and this will result in a tree like this, and your new X is shown here. Now, after this, you will do case 3. So, just as I mentioned earlier, if X is the right child of the parent, you'll do case 2 and case 3. Otherwise, you will just do case 3. Now, having done this, you have now come to case 3. What you will do in case 3 is you will right rotate C. You will right rotate C, which will bring C down like this. It is going to move B up to C's position, and the right subtree of B will now become the left subtree of C, and you will have a tree like the one here. At this point, actually no more violations in the red-black tree will exist if you enter this particular scenario, and you'll actually exit out of the while loop. Okay, so with this, what we have studied is how to insert a node in a red-black tree.